Yo, what's good? We got a question on electrochemistry. I literally learned this like 5 minutes ago, so we're gonna see if I can get this right the first time. So we're gonna determine the equilibrium constant from cell potential. Now, what I know is that we're gonna use an equation. What equation are we gonna use? Look, we already forgot. We need to find equilibrium constant. Okay, so we're gonna use this. Bro, bro, what the heck? Wait, oh, it's the wrong pen. That's okay. E cell is going to be equal to E cell naught. That was ugly. E cell is going to be equal to E cell naught minus 0.0592 volts. This is a Nernst equation, I believe. Log Q. Okay, so from what I understand, the first couple of steps, or the first step is to separate these into two half reactions, then find out what the EA and EC are, find out the standard of whatever they are, and then from there, I'm low-key already lost. Okay, determine the equilibrium constant for that. Bro, I literally got this, bro. It can't be hard. Okay, so at equilibrium, something I guess I just know now is that E cell is going to be equal to 0 at equilibrium. Why did I say like that? So, okay, wait, this is low-key easy now. I see it. I understand. Because we're only looking for this. This is the question mark. That's what we need to find. So we're just going to find that out. What do we need to know? Well, we need to know N, which we can find. E cell is going to be 0, so we don't need to worry about that. And E naught, we can find that out as well. So we're going to do that. Okay, so first step, what I think we should do is separate these two equations into two. Because we need to find the standard cell potential. So Sn2 plus 2 electrons is going to give Sn solid, and then nickel solid is going to give nickel 2 plus 2 electrons. So from this, we already know that N is going to be equal to 2 because there's 2 electrons being transferred. Now we just need to find out what each one is. Okay, wait, so which one's going to be? Okay, so is this tin, right? Tin is gaining electrons, yeah, because it's a reactant. So gaining electrons, this is undergoing reduction, and reduction, that means it's gaining electrons. So that means this is the cathode, yeah, because the electrons go to the cathode. Cations and electrons go to the cathode. Oxidation, anode. Okay, boom. Now we just need to find out these values. So something else I learned is that, I'm just stating facts now, but something I learned is that we just use the reduction potentials when we're using the Nernst equation. So we don't have to flip it, we don't have to manipulate it anyway, we just use that value straight up. So we're going to do that. Sn2 plus, on the data sheet here, it shows negative 0.138. I'm hoping the microphone isn't touching the zipper right now. Negative 0.138. Let me just in case. Okay, negative 0.138 volts. This is going to be equal to EC. And what's nickel? Wow, I wish they had this like alphabetical or something, bro. Actually, wait, it's organized by like highest reduction potential, so I guess it makes sense. But nickel, oh, it's negative 0.257. Okay, so now we know that E cell, this is just a formula that I think you should know, is going to be equal to E cathode minus E anode. Bro, my iPad is like heating up. It's like warm. Okay, so EC is negative 0.138 volts. Whoops. Minus negative 0.257 volts. Now, what does the calculator say this is equal to? Bro, I have an econ final and I'm genuinely like cooked for this, bro. 0.119. Okay. Progress is being made. Okay, so we got that. 0.119 volts. Okay, so now we're going to just work on this equation now. Yo, it's like the right side of my iPad is warm, but my left side's like cold. It's kind of interesting. Maybe I should just flip the iPad around. There you go. Look at that, problem solved. Okay, so where were we now? Okay, we need to manipulate this. Okay, so E cell is going to be equal to 0. So we could simply just move the standard to the other side. So we're going to get negative E cell is equal to negative 0.0592 volts over N, and N is equal to 2 because we got 2 electrons. Multiplied by log, and this, because this is an equilibrium constant, we can call this K, because K is the equilibrium constant, Q is the reaction quotient. So in any case, when it's at equilibrium, we use K. That's also something my prof just said. So now we're going to substitute these values in. Negative, okay, so we could just cancel out these negatives. Positive, positive. 0.119 volts. Okay, now the other side of the iPad is warm. I don't know. Okay, multiplied by, because we're dividing, so we need to flip it. Volts cancel out. .02. So now how do you solve for K? Well, one way you could think of it is just writing out the base. So now we just need to find out 10 to the power of, we just need to find out 10 to the power of 4.02. Wait, that's wrong. Did I do that right? Wait, hold on. Bro, I literally did this like 5 minutes ago and I'm getting the wrong answer. Oh, I forgot to divide by 2, yeah? Whoops. Oh no, I did divide by 2. 4.02. Wait, I feel like I'm missing a negative somewhere. Let me just try this again. 0.119 multiplied by 2 divided by 0.0592, 10 to the power of... Yo, did I forget how to do... Wait, is it... Wait, what? Yo, bro, what? Yo, I swear, this is common sense, bro. How am I tweaking the last... I'm choking, bro. Wow, my calculator ran out of... Bro, how did I even do this, bro? Yo. Am I being slow somewhere? Log K. Yo, something is weird, bro. How am I not? 0.0592, bro, 0.119. Okay, 4.022. So how do you... Wait. Yo, how do you inverse the log? How do you do the opposite? Bro, you put it to... What? Nah, no way I'm selling myself right now. Yo. Okay, let me just look through my notes real quick. Shrink. Hmm. .72. So if I use 0.119, that's wrong. But that's the value they give you in the formula sheet, bruv. Yo, okay, so you get 5.2 times 10 to the 3, right? Okay, now I'm going to do this with the 0.119. Okay, so you get 4.02. That's barely a difference. You get 10 to the power. You get 10.5 to the power of 3. Ain't that sound like a big difference? Well, I guess based on what we have here, K is going to be equal to 10.5 times 10 to the 3. There's our answer, bro. I really don't know why I tweaked so much on the bottom part, but yeah, that's pretty much it. I'll see you tomorrow.